the students in our YouTube channel Physics by TC Chauhan sir. We are with Airforce Special and we are taking topic simple harmonic motion, which is very important in different aspects. In recent competitive examination like Airforce, Navy, NDA, several questions are asked, and very possible that the questions based upon this are going to be asked in near future examination. Now, what does it mean by harmonic motion? The motion in which the object is taking place, its variation in its path about a particular mean position in such a way that the repetition takes place after a certain interval, that is known as harmonic motion. Like circular motion can be taken as harmonic motion because in this motion its repetition of path takes place after a certain interval of time, and that interval of time is known as time period. In the same way, there is frequency, that is number of cycles taking place per second. This is harmonic motion. Now, what about simple harmonic motion? Whenever we discuss about harmonic motion in which motion takes place about mean position. Simple harmonic motion takes place about mean position, but the acceleration and restoring force should be towards mean position. That means F proportional minus X, F is equal to M into A, then A proportional minus X. The restoring force should be directly proportional to displacement and restoring acceleration should be directly proportional to displacement, but this should act toward mean position. This is the condition. Now, the question is, what does it mean by simple harmonic motion? The answer is, it means the motion about mean position, to and fro motion, in which restoring force is directly proportional to displacement acting toward mean position. The second question is, what are types of SHM, simple harmonic motion? Types of SHM. There are two types of SHM. First is linear and second is angular. The another question is, what is condition of linear simple harmonic motion? This is force directly proportional to negative value of displacement. What is condition of angular simple harmonic motion? That is, torque should be directly proportional angular displacement. Then here A proportional minus X, here alpha proportional minus theta. Angular displacement is represented by theta. Now another question is, what is practical application of linear SHM or practical example? The practical example of linear SHM is the motion of a loaded spring or spring when it is shifted from its mean position. Let shift is X, then F proportional minus X. What is example of angular SHM? An example of angular SHM is a simple pendulum which is going to move to and fro on an arc about a certain angle, then torque will be directly proportional minus theta. So these are the examples and these are the conditions. Now another question is, what is time period in simple harmonic motion? Time period of simple harmonic motion is T is equal to 2 pi under root M by K. K is spring constant or proportional constant taking place. M is mass suspended which is taking place. What about time period of SHM when it is not suspended from a spring, it is suspended by a wire or by a thread? Then it will be a simple pendulum and its time period will be 2 pi under root L upon G. These are two major questions. Now, what about the numerical question? The first numerical question is based upon simple pendulum. If simple pendulum is kept in a lift and lift is accelerated upwards, then what about time period? Length of pendulum is L. The time period will be T is equal to 2 pi under root L upon G plus A as it is moving upward. Then what happen about time period? Whether it will increase or decrease. When accelerated upward, then the denominator value is going to increase. then numerator will decrease, so time period will decrease. In this case it is very important. Another numerical question is, when lift is moving downwards with certain acceleration, then the numerical question will be, what about the time period? T is equal to 2 pi under root L upon G minus A. Then time period will increase as the acceleration or effective acceleration is going to be decreased. Now what about another question? When lift is freely falling, that means its acceleration is g and it is downward. In this case the time period will be 2 pi under root L upon G minus G. Denominator will be 0, and when it will be 0, time period will be infinite. Now the question arises, what does it mean by infinite time period? It means the simple pendulum which is moving will stop at a particular place and it will not return back towards its mean position. Then we can say its time period will be infinite. Now another question about simple pendulum is, if there is a car in which simple pendulum is there, or there is a truck in which simple pendulum, we are taking example of a car in which simple pendulum is suspended, then what happen about its time period? What about its time period? Let us discuss about that. If car is accelerated with certain acceleration, then time period will be t is equal to 2 pi under root L upon G square plus A square to the power 1 by 2. This quantity is going to be increased, then time period is going to be decreased if it is accelerated. Now another logical question, which are, if lift is moving downwards or moving upward with constant velocity, then acceleration will be 0, time period will does not change, t is equal to 2 pi under root L by G. Remember, when acceleration is not there, velocity is constant. It can be taken in the case of a car which is moving. Then what about the time period? If it is not acceleration, acceleration is 0, velocity is constant, time period does not change again. Same formula applicable again in this case. Now what about the displacement of particle in SHM? Displacement of particle in SHM is given by y is equal to a sine omega t minus kx plus phi. Here there is certain change. We can take kx is equal to 0. Then y will be a sine omega t plus phi or minus phi depending upon the condition. Question arises, what about A? It is amplitude. What about amplitude? Amplitude is maximum displacement taking place from mean position. This is mean position and this is maximum displacement which is taking place. It can be said as amplitude. If it is linear, then maximum displacement from mean position, that is A. This is amplitude. This is displacement of particle in SHM. Omega is angular velocity. Omega can be 2 pi f or 2 pi upon t. Remember, f is frequency, t is time period, omega is angular frequency, angular velocity. Phi is phase difference. You can take initial phase difference. If initial phase angle is 0, then y will be a sine omega t only. This is displacement. Sometime question can be asked in two parts, like displacement is y is equal to a sine omega t plus b cos omega t. What happened in this case? What about the resultant amplitude? Resultant amplitude will be r is equal to under root a square plus b square. A and b are the constant which are taking place. What about the phase difference? In this case, phase difference will be tan theta is equal to b upon ab by a. This is all about. Numerical can be in this way. Question: if y is equal to 5 sine 100 pi t plus 6 sine 100 pi t, 6 cos 100 pi t, not sine here. Here there will be cos. Then what about these 5 and 6? These are A and B. A is equal to 5, B is equal to 6. Then what about the resultant amplitude? This will be R under root A square plus B square under root of 5 square plus 6 square. Then square root of 25 plus 36. This will be resultant amplitude in this case. Now, what about resultant phase difference? By using this, you can find resultant phase difference. This can be tan theta is equal to B by A, and that will be 6 by 5. So, such kind of numerical can be asked on this. Then, what about the velocity of particle in SHM? Several questions can be made on this. Velocity is rate of change of displacement, that is dy upon dt. Y, you know, y is equal to a sine omega t. By putting this and differentiating, we will have v is equal to a omega cos omega t. This is velocity of particle in a SHM, and this is about maximum velocity. Maximum velocity is v maximum is equal to a omega. Remember, now numerical can be based upon this in this way, that at what time the velocity of particle become equal to maximum velocity. Question is, at what time means you have to find time. The velocity v become maximum velocity, that is v maximum. You know v maximum is equal to a omega. The question will be v is equal to a omega cos omega t. Now what about v? That is maximum. That will be a omega is equal to a omega cos omega t. This a omega will get cancelled. There will be 1. In cos, the value of 1 is cos 0 or cos 2 pi or cos 4 pi. In this way, then it will be cos omega t. Now you should take 2 pi in place of 0. Then it will be 2 pi is equal to omega. Omega is 2 pi upon t, and that will be small t. This pi will get cancelled. 2 get cancelled. You will have t is equal to capital T. So maximum velocity will be at position of time period, at position of 0, etc. Now this is mathematical answer. Now let us move toward theoretical answer. Whenever there is a simple pendulum which is moving in this way, it is at maximum position, it is at minimum position. The minimum position is at t is equal to 0. You will find here the velocity will be maximum. So this question is verified here, that velocity will maximum at mean position. You can say at t is equal to 0. Now another question. Another question is, what about the velocity in terms of displacement? Remember student, it is very important question. Velocity in terms of displacement is given by a omega cos omega t. Then we have to convert this in terms of displacement. Then v is equal to omega under root a square minus y square. In converting cos into sine and then putting values, you have to learn it directly. You need not to convert, you have to learn it directly. Omega will be angular velocity, omega is 2 pi upon t, y is displacement. Now numerical can be asked on it. What about the numerical? What about the velocity when the position of particle is at half of the displacement? Let us discuss. Y is equal to a by 2, maximum amplitude, half of the maximum amplitude. Then velocity v will be omega under root a square minus a square by 4. This a by 2 is placed here. Then we will have this value, and v is equal to omega under root 3a square by 4. Then you will get the result, and that will be under root omega a root 3 by 2. This is velocity at that place. Now let us discuss about acceleration. Acceleration is given by rate of change of velocity, that is dv upon dt. V is given by a omega cos omega t. if you are going to put this value here, acceleration will be minus a omega square sine omega t. Again, the result is there, a is equal to minus omega square y, a proportional minus y. So there are two basic relations upon this. And what about the questions? The question can be how acceleration changes with displacement. Acceleration will change with displacement as minus of y. Now, graphical question. The several important graphs are asked on this. The question can be, let us discuss about displacement time graph in SHM. Y is equal to a sine omega t. This will be sinusoidal curve. Remember, this is the first question. This is a, this is time period t, this is t by 2, this is 0. So this is about displacement time graph, remember. Now what about velocity time graph? You know velocity will be a omega cos omega t. It should be cosine graph. Cosine graph will start from the maximum position, and in this way velocity time curve, it is 0, it is t. Now how does the value changes? This value will be a omega and this value will be minus a omega. These are maximum value in positive direction, these are maximum value in negative direction. Now another graph which can be graph between velocity and displacement, it is very important. For this purpose a relation is required, and that relation is v square upon a omega whole square. You have to learn this relation, plus y square upon a square is equal to 1. This relation is very much identical to equation of ellipse. So this graph will be elliptical in this way. If you are putting here velocity, here displacement, this major axis will be a omega and this minor axis will be a. It is important, very important. Axis can be changed. If axis is changed in this way, here we are taking velocity and here we are taking displacement, then graph will be in this way. This is major, this is minor axis and this is major axis. Now another question is, what about acceleration displacement graph? This question is, if acceleration is given by omega square a sine omega t, negative sign is there, then graph will be like this, start from negative towards positive. This is time, this is acceleration. It is very important. So what about another question? The graph between acceleration and displacement, a proportional minus y, so its graph will be in this way for negative axis. When this is displacement, this is acceleration. When displacement is positive, acceleration become negative, and when displacement is negative, then acceleration become positive. So these are few important graphs or few important curves. Now we discuss about energy of particle in SHM. Energy of particle in SHM can be in terms of potential, can be in terms of kinetic, can be in terms of mechanical. Let us discuss about potential energy. Potential energy in SHM is U is equal to half ky square. Y you know, a sine omega t. Then potential energy will be half ka square sine square omega t. It is very important. Now the question is, first question is, what is maximum kinetic energy? Remember, maximum kinetic energy is half ka square. Second question is, what is average kinetic energy? Remember, average kinetic energy is 1 by 4 ka square. Question arises, why it is 1 by 4? Because average value of sine square omega t is 1 by 2. That's why it will become 1 by 4. Its average value is 1 by 2. That's why it will become 1 by 4. Remember. Now, what about the graph between potential energy and time? You know, potential energy is half k a square sine square omega t. So negative axis graph will not exist. The graph will be in this way. This is potential energy, this is time. The graph will move only above the axis in positive direction. So this is about potential energy graph. Now these are few questions. Now what about kinetic energy? Kinetic energy is K is equal to Ek. You can write Ek is equal to half mv square. You know V is a omega cos omega t. Then kinetic energy Ek will be half m omega square a square cos square omega t. What about m omega square? It is represented by k. So it will be half k a square cos square omega t. Now the questions. What about maximum kinetic energy? Maximum kinetic energy Ek maximum will be half k a square. It is very important. Another question is, what about average kinetic energy? You know, average value of sine square omega t is 1 by 2. Then same average value of cos square omega t will also be 1 by 2. Then the average kinetic energy will be 1 by 4 k a square. Remember, it is very important. Average kinetic energy is 1 by 4 k a square. Now what about graph? The graph between kinetic energy and time is in such a way, it is very important. It has been asked in several competitive exams and important for Airforce. This graph will move only above the axis because it is positive. Square is there, cos square is there. Then what about changes? It will start from top and move in this way, like this is the kinetic energy graph. This value will remain constant. This is maximum value. The maximum value of kinetic energy is half k a square. Now what about mechanical energy? Mechanical energy is sum of kinetic energy and potential energy. Then its result will be half k a square. Now the question arises, what about the graph? Since it does not depend upon time at all, so its graph will be straight line, and in such a way this will be the graph, this mechanical energy, and this is time. So this is about curves or graphs. Now another question can be, you have to identify which is graph of kinetic energy, which is graph of potential energy, which is graph of mechanical energy, which is graph of maximum energy, which is graph of average energy. It is for combined curve. See, this is time, this is energy, any kind of energy. The graph will be represented in such a way. If this graph is there, it will be for potential energy. Remember, if graph is in this way, it is maximum at 0. This graph will represent kinetic energy. Remember, it is kinetic energy. Now what about this curve? This graph is for mechanical energy or total energy. This is for total energy. Now what about this graph? Listen carefully. What about this graph? It is for average energy. Average energy. Either average kinetic or average potential energy. Now, what about pendulum? This question is very important. In the case of pendulum, whenever a rigid support is there and a bob is suspended, which is of certain mass and allowed to move on an arc, then it will move in this way this will be theta, this will be arc, this will be theta. Here length of pendulum is L, mass of bob is m. It is not taken in consideration. Only length and acceleration due to gravity will take place its role. Then its time period will be t is equal to 2 pi under root L by g. I have told you earlier. Now, what about the questions? Sometimes it has been asked that if mass of pendulum is increased, what is effect on time period? No effect at all. Another question is, if length is increased, what about the effect of time period? It will increase. Now the question arises, if a pendulum is filled with certain liquid and liquid is going to be slightly moving out, then after some time its center of mass will get shifted, then effective length will increase, and when effective length will increase, then time period will increase. Remember, when it will move out slowly, then after some time the time period will go on increasing. This is all about the time period of simple pendulum. So these are questions based upon pendulum, simple harmonic motion, velocity of particle, etc. So this is all about. I think this session will be very useful for upcoming examinations. You should like our channel, you should subscribe our channel, you should share our channel, and you get benefit, and say all the students which are preparing for upcoming examinations, thank you very much.